Alright, so we're going to finish up our last section here in section 5.1. This will be our last section of this class. When you finish this video and you finish your homework, you should be ready to review for your final exam, and you should be getting close to being ready to take your final. And so hopefully you're excited about finishing up and moving into your summer and probably taking a little break. So last section, section 5.1, deals with systems of linear equations. Now, a system of equations is a set of equations that we look at the same time. We consider simultaneously. And the solution set is a set of order pair, or an order pair, where the equations would intersect. For example, if you take one equation and you graph it, and you take another equation and you graph it, the solution to the system of equations is this point, this order pair, where those two lines would cross, where they would intersect. And you can do a couple different methods. You can do what we call the substitution method, where you solve for a variable in one equation, put that into the other equation, solve, and then substitute again. And that can be very, very simple, but sometimes it can be kind of complicated too. And so what I like to do is use the elimination method. And this is the method I'm going to show you on a couple of examples that we're going to see today. I'm going to show you the elimination method. And what it does is it allows us to get the x's or y's to be the same number, same coefficient, with the opposite sign, and then add those together, add those equations together. When we do, one variable is going to be eliminated, and you'll solve for the other. And then once you find that, you'll put it back in to one of the original equations and solve for the other variable. So every one of these is going to have a solution that is an ordered pair. Okay, so just understand that. We're looking for an ordered pair for our solution. And like I said, you can do the substitution method. We are going to do, or the way I'm going to show you, is the elimination method. I personally think it's easier because you can use it every time without any kind of problems. Again, sometimes the substitution method can be kind of difficult and can be kind of troublesome to use. And so I prefer to use the elimination method. I think it'll be easier for you to really only have to memorize one method and understand how it works, even though the other one does work as well. So let's jump right in. Let's look at how we're going to do this. So when we solve the system of equations, again, we're going to use the elimination method. So you may want to write that down somewhere. And I'm going to use this method for all of the equations we're going to solve. The way this works is you take one of the variables, you pick which one, doesn't matter, x or y, and you want to get rid of one of those variables. So to do that, you need the coefficients of these to be the same number and the same and opposite signs. And so sometimes that's easy because it's easy to pick out. Maybe they're already different signs, or maybe they're already same number with different signs. And if that's the case, then that really helps. In this case, though, you'll notice that the y values have the same number and the x values also have the same number. I mean, same signs. So what I'm going to suggest to you is to take the bottom equation and multiply everything in it by -4. Now, somebody says, why -4? Well, because when I multiply -4 times x, I'm going to get -4x. And when I add these equations together, it's going to allow me to get rid of that x variable. Okay? So I'm just going to rewrite this to the side. I'm going to leave the first equation the way it is. I'm not multiplying it by anything because it already has the 4x. I'm going to make the x in the second equation be -4x. Okay? So again, trying to get those to be same variable, same coefficient, opposite signs. So I'm going to leave the 4x minus 3y equals 14. And then with the bottom equation, again, I'm going to multiply everything by negative 4. So it's going to be negative 4x plus 8y equals negative 4. And then I'm going to add these equations together. And so when I add them together, the 4x minus 4x goes away. It eliminates the x. That's what we wanted. And you'll notice that negative 3y plus 8y is 5y. And 14 minus 4 is 10. Well, now we can just solve for y. So we'll divide by 5. And we'll get y is equal to 2. Now, that's one of our numbers we're looking for. But we still got to have x. And so I'm going to take this 2 and put it back into one of the equations. It doesn't matter which one. And I'm going to put it back into this bottom equation because my numbers are smaller. I don't have to worry about the 14. It's just going to seems to be a little bit easier based on the numbers being smaller. So in that equation, I'm going to take the y value of 2 and substitute it in. And then just solve for x. And so this is x minus 4 equals 1. And we'll add 4. And we'll get x is equal to 5. Well, there's my x value. So the ordered pair that makes this equation true is 5, 3. I'm sorry, 5, 2. 5, 2, not 3. 5, 2. Now, this is the ordered pair that makes both equations true. In other words, that is a point that is on both lines. It is where these lines would cross if you were to graph them. That is what we're looking for. This elimination process is done basically the same way with every problem. You eliminate one variable, like we did here, solve for the other, then put that variable back in, and then solve for the other one that you don't have. Okay? If you have any questions about that, let me know. I'll be glad to go through that in more detail with you. We're going to look at a couple others. I think this will help as we look at a couple others, but if you have questions, definitely let me know. So look at this one. So this time we need, again, to eliminate either the x variable or the y variable, and it doesn't matter which one. I'm going to choose the y variable, and the reason is because I already noticed that I have opposite signs. So I don't have to worry about multiplying by a negative or anything of that sort. I simply can multiply by positive numbers, and I can make these y values be the same. So, in the first equation, what do I need to multiply by to make it be a number that will cancel with the y value on bottom? And what does the one on bottom need to be multiplied by? Well, hopefully you look at that and you say, well, I can make them both be 6, right? If I multiply this top equation by 2, then 2 times 3y is going to be 6y. And if I multiply the bottom equation by 3, then 3 times negative 2y is going to be negative 6y. That should allow us to cancel them out. Okay, so we're just trying to figure out how do we make both the coefficients, numbers in front of the variable, the same number but with the opposite signs. Well, they already had the opposite signs. We just need to make them the same number. So in the top equation, we're going to multiply everything by 2. And so when we do, we're going to get 4x plus 6y equals negative 2. And then on the bottom equation, we're going to do the same thing. We're going to multiply by 3, and we're going to get 9x minus 6y. And then 18 times 3 is 54. And so now I can take those two equations and add them together. So 4x plus 9x is going to be 13x. 6y minus 6y is going to cancel, and negative 2 plus 54 is 52. And so now we just need to solve for x. And so we'll divide by 13. And we'll find out that x is equal to 4. Again, there's one of my values. Well, now we need to take that x and put it back into one of the equations. Again, doesn't matter which one, but put it back in for x. And again, I'm going to put it back in the first equation because the first equation has smaller numbers. I don't have to deal with the 18, and so it's going to keep my numbers smaller, which means probably going to be easier numbers. So if I take the 4 and put it back in the first equation, it's 2 times 4 plus 3y equals negative 1. So that's 8 plus 3y equals negative 1. And we'll subtract 8. And we're going to get 3y is equal to negative 9. And we'll divide by 3. And we'll find out y is equal to negative 3. So the ordered pair that is a solution to both equations has to be 4, negative 3. Now notice I put the 4 first because it is the x value. The y value has to be the second number every single time. Again, very similar process to what we did in the previous problem. This time we multiplied both equations by a number so they could become the 6y and negative 6y. The y values could. If you have questions about that one, let me know. So on this last one, I would like you to try this one on your own. So pause the video, try it on your own, and then come back when you get it finished. So hopefully you did that. You paused the video, you worked this one, and hopefully have your solutions without a lot of issues. Now, again, you can get rid of x or y first. It doesn't matter. I'm going to choose the y because, again, I notice that they're already opposite signs. And so if I can multiply those y values by something to make them be the same, then I'm going to be able to get rid of the y value. So I'm going to take both equations, multiply them by something. And so in the top equation, we're going to multiply by 3 because 3 times 4, the negative 4y is going to be negative 12y, which means that I can multiply the bottom equation by 4, and 4 times 3y is going to be 12y. And so we should be able to get rid of the y value by doing that. So in the top equation, multiply by 3, we'll get 9x minus 12y equals 3. And then in the bottom equation, we're going to multiply by 4. And so we're going to have 8x plus 12y. Again, that's the purpose. We want to get 12y there. And then 12 times 4 is going to be 48. So now when we add these two equations together, the 9x plus 8x is 17x. The negative 12y plus 12y cancels, which is what we wanted. And 48 plus 3 is going to be 51. And so then we just need to solve for x. So we'll take the 17x and divide by 17 on both sides, and we'll find x is 3. Well, again, there's part of the answer. The other part is to take that 3 and put it back in one of the equations. Again, I'm going to choose the top equation just because it's got smaller numbers. And so if you put it back in the top equation, we have 3 times 3 minus 4y equals 1. 3 times 3 is 9, minus 4y equals 1. And then we'll subtract 9, and we'll get negative 4y is equal to negative 8, and divide by negative 4, and you'll get y is equal to 2. So there's the other part of the ordered pair. So the ordered pair that makes both equations true, or that is the intersection point for both of these, has to be 3, 2. Now, you may look at this and say, well, I want to get rid of the x first. Well, that's fine. You could do that. You could multiply the top equation by 2 or -2 and the bottom equation by 3 or -3 and make them be 6 and -6. And that would still work. You'd still be able to solve and get the same ordered pair. I don't care how you go about solving, as long as you're able to get that ordered pair and find that it is 3, 2. This finishes chapter 5, the only section of chapter 5 we're doing. We are now ready to prepare for the final exam. Your tests covering chapter 4 and this section of chapter 5 will strictly be the exam. So you won't have an additional test on these 4 sections. You'll just be ready to take your test. So you'll have information coming from me about the test very, very shortly. If you have any questions or anything, let me know and I'll try to answer any questions.